MTN College is situated at number 36 Addison House, corner Terminus Street and Oxford Street. We have MATRIC reliant in all subjects and extra lessons, grade 10 to 12, mainly in mathematics and physical sciences. We shall be broadcasting live lessons 3 times a week, that is Monday, Wednesday, and Friday, on our Facebook page as well as our YouTube channel. Today, we shall start our mathematics sessions. This is actually the first one, and as for today, we shall start with exponents and surds as it has been written on the board. Before we start the exponents, or before we go into details of surds and exponents, we shall first see the type of numbers. There are 2 types of numbers. The first type is real numbers. As we hear the word real, so these numbers are real. And if you put them into the calculator, you can do any calculation with them, and the calculator will be able to give you the answer. Then the second type of numbers is non-real. Non-real numbers. This one is mostly imaginary. For example, if you get the square root of a negative number, definitely the calculator won't give you that because it is a non-real number. So non-real numbers have got real part and imaginary part, but those in actual sense they do not exist. So they are non-real. Mostly in grade 12 we shall be focusing on real numbers. So what we are going to do is stating the types of real numbers, because however much real numbers a section of numbers, we also have different types of real numbers. The first one, part A, we shall see or explain natural numbers. Now you can ask yourself, what are natural numbers? Natural numbers are denoted by capital N. And these natural numbers, it can be a set of all positive numbers, positive whole numbers. That is from 1, 2, 3, 4, and so on, up to infinity. The second type of numbers, real numbers, is the whole numbers. Whole numbers are denoted by N naught. N naught by, because all numbers start with 0, 1, 2, 3, up to infinity. So there is a difference. The difference between natural numbers and whole numbers, that whole numbers start with 0, whereas natural numbers start with 1. The third type of numbers, real numbers, integers. Integers, if you hear of integers, then you get to know that we are talking about numbers on the number line, and these numbers are denoted by Z. So a set of integers will be from negative infinity, maybe up to negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on up to infinity, which means, in other words, that integers are numbers from negative infinity to positive infinity. Then the next type of real numbers is rational. Rational numbers. As you hear the word rational, these are numbers that can be expressed in form of A over B, can be expressed in form of A over B. If a number cannot be expressed in that form, then it's not a rational number. And we know that if it is expressed in the form A over B, A and B are numbers taken from the set of integers, and B must not be equal to 0. B must not be equal to 0, because if any number is over 0, that number also we can say that does not exist. The last type of real numbers, is the irrational numbers. That's where our focus is. Because from irrational numbers, we shall here be able to see the surds, irrational numbers. These are the types of numbers that cannot be expressed in the form A over B. And this example, you can talk of root of 2. When you get root of 2, it's 1.41, what, it goes, it continues. So root of 2, root of 3, root of 4 is not an irrational number, because when you get the root of 4, it is going to be 2, which is actually maybe a natural number, or number, or an integer. There is also pi. Pi is also an irrational number. So the irrational numbers that we are going to be seeing mostly are the roots of some numbers whose roots you cannot be able to get easily. So now from there we are going direct to surds, because as we've said, surds are the irrational numbers. So now all numbers, or all square roots, also all cube roots, etc. are not rational numbers. They are not rational numbers, and they are called surds. So that is root 2, root 3, as indicated, root 2, root 3, root 5, root 6, root 7, and so on. All those are surds. So we shall have an example, we shall not waste time. The first example will be saying simplify. Simplify, that is example 1. Simplify the cube root of 8 over 27. If they give you something like that, what do you do? A cube root is the same as like 8 over 27. We know very well that in surds, the solution for this cube root, you see, you make sure that the 3 is inside there. 8 over 27 is the same as saying cube root of 8 divided by cube root of 27. So now, this one you can even say that it's the same as 8 power a third over 27 power a third. But what is 8? 8 is the same as 2 power 3 power a third divided by. So 27 is the same as 3 power 3 power a third. So now, in solving that further, we shall see that the 3 times a third, because when the 2 powers, you just multiply them. For example, 2 power 3 power a third, you just say it's 2 power 3 times a third, which will give us times a third over 3 power 3 times a third, and therefore you see that you are going to be remaining with 2 power 1 over 3 power 1, and our answer becomes 2 over 3. That is our example 1. Our example 2, the second example, as we are seeing the surds. The second example is example B, example 2. Example 2, simplify. It says simplify 9 plus root of 45 over 3. So now, what do you do with this one? The solution to this, we shall say this is 9 plus this root of 45. We want to simplify the root of 45. 45 is the same as 9 times 5 over 3. So now, when you are multiplying these two numbers under the root, you can split them by saying that this is the same as 9 plus root of 9 times root of 5 over 3. So now, that will give us 9 plus, what's root of 9? It is 3. Times root of 5 over 3. But when we look at this, there is a common 3 in these two terms, which can be divided by a 3 that is down there. And therefore, we come up with 3 plus root of 5 as our final answer. The last example that we are going to do, as we are going to do 3 examples, we're going to do 3 examples. Example 3, it says simplify 3 over root of 3 minus 1. So when you look at this, our main target or the task that we have is to remove the root of 3. To remove any root from the denominator. This is the numerator, the 3. The denominator is root 3 minus 1. So what do we do? There is what we call rationalization. To rationalize. How to rationalize? You make sure that the denominator, you multiply it by the same number but with a different sign. That is, if it was the minus, then you multiply it with the same expression but with a plus. So this is going to be 3 over root 3 minus 1 times root 3 plus 1. And also you do the same thing in the numerator. Why? Because if you do the same thing, it's like you don't change anything in the expression. Still, the root 3 plus 1 can cancel the root 3 plus 1 down. So now, the purpose of putting a plus is because we want to achieve a difference of 2 squares. That difference of 2 squares is going to eliminate the root. And therefore, when we solve, 3 times root 3 is 3 root 3. And then 3 times 1 is 3 over. So the difference of 2 squares here, it is root 3 squared minus 1 squared, which is 1. And therefore, finally, we shall get 3 root 3 plus 3 over root 3 squared is 3 minus 1. And that is giving us 3 root 3 plus 3 over 2. You can further say that you factorize out 3 and say that this is 3 into root 3 plus 1 over 2. And that is our final answer. For today, we shall stop there, and then tomorrow we shall be able to see exponents. We shall see exponents and do numbers and even go in details. Then from there, we shall be able to give an exercise that can help someone when it all